Okay, so like imagine you're trying to keep track of where everyone sits in your class, right?
Right.
Or like maybe you're trying to remember the scores for everyone in like your last Mario Kart game.
Mm-hmm.
You can try to like memorize everything, but that's kind of a pain.
Yeah, totally.
Wouldn't it be way easier to like use Python to do that for you?
Yeah.
Well, today we're going to deep dive into this super useful Python tool that helps you organize stuff like that. It's called a 2D list.
Yeah, if you've already learned about like regular Python lists and how functions can give back values, then 2D lists are like the next step. They're really good for structuring your data.
Okay, so I get that they're like lists, but what makes them 2D?
So think of it like a spreadsheet, rows and columns. A 2D list in Python basically lets you create that same kind of grid. Like imagine a simple table with some numbers.
Right.
Like say we have 986 on the top row.
Okay.
And then 475 on the bottom row. So 2 rows and 3 columns.
Got it. So like a 2x3 grid.
Exactly. In Python, we write this as a list of lists. So that little number grid would become this. L equals open bracket 9, comma 8, comma 6, close bracket, open bracket, 4, comma 7, comma 5, close bracket. Each inner list is a row in our grid.
Oh, okay, I see that. So the first one, open bracket 9, comma 8, comma 6, close bracket, that's the top row. And the second one, open bracket 4, comma 7, comma 5, close bracket, is the bottom row. Cool. But how do we, like, grab a specific number out of this 2D list?
That's where indexing comes in. It's like the key to 2D lists. You use 2 sets of square brackets. The first one tells Python which row you want, and the second one tells Python which column in that row. Just remember, Python starts counting from 0, not 1.
Right, okay.
So L, open bracket, 0, close bracket, would actually give you the whole first row, which is open bracket 9, comma 8, comma 6, close bracket.
Okay.
To get a single number, like let's say the 6, which is in the first row, so index 0, and the third column, so index 2, we'd use L, open bracket, 0, close bracket, open bracket 2, close bracket.
Got it. So L, open bracket, 0, close bracket, open bracket, 2, close bracket gives us 6.
Yeah.
So then L, open bracket, 1, close bracket, open bracket, 0, close bracket would be the 4, right?
Yeah.
Because it's the second row index 1, first column index 0.
Exactly.
Okay. Got it. All right, I think I'm getting this.
Awesome.
Now let's look at a couple of examples. Our source has this question. What's the value of L, open bracket, 0, close bracket, open bracket, 1, close bracket?
Let's see. So L, open bracket, 0, close bracket, that gives us the list, open bracket 9, comma 8, comma 6, close bracket, right? And then within that list, the element at index 1 is 8. So the answer is 8. The source also points out that saying L, open bracket, 0, close bracket, open bracket, 1, close bracket doesn't exist is wrong.
Yeah, it's totally there. Right smack in the middle of that first row. Okay, now the source has another question, which is a little trickier. What is the value of L, open bracket, 2, close bracket, open bracket, 1, close bracket? And the options are 5, 6, and 7.
Okay, so this one is a bit of a trick question. The correct answer is that L, open bracket, 2, close bracket, open bracket, 1, close bracket actually doesn't exist.
Why not?
Remember, our 2D list L only has 2 inner lists, which means it only has 2 rows.
Right.
Python counts those rows as index 0 and index 1. There's no row at index 2. So asking for L, open bracket, 2, close bracket is like trying to find a row that just isn't there.
Okay. Yeah, that makes sense. We can only ask for rows that we actually have.
Yeah.
So far, so good.
Hey.
Now, what about going through all the items in a 2D list? With a normal list, we could use a for loop. But how do we handle both the rows and columns in a 2D list?
That's where we use something called nested loops. Since we have these lists inside another list, we need one loop to go through the outer list and then another loop inside that one to go through each inner list.
Oh, I see. So it's like opening up a box and then opening up another box inside that first box.
Yeah, exactly. The outer loop opens the first box, which is a row in our list.
Okay.
And then the inner loop goes through all the items in that smaller box, which are the individual numbers or whatever in that row.
That's pretty cool.
The source gives this really good example. It's called the Looping Over 2D Lists demo, and it uses a 2D list called app.colors.
Okay.
It looks like this. App.colors equals open bracket, quote, red quote, comma, quote, orange quote, comma, quote, yellow quote, close bracket, comma, open bracket, quote, green quote, blue quote, comma, quote, purple, close bracket, close bracket.
So this 2D list has colors in it instead of numbers.
Right, and they show how you can use nested for loops to go through each color in the list. The code looks something like this. For row in range, open parenthesis, 2, close parenthesis, colon.
Okay.
Then indented on the next line, 4 in range, open parenthesis, 3, close parenthesis, colon. And then indented even further on the next line, color equals app.colors, open bracket row, close bracket, open bracket, close bracket.
Okay, so what's happening here?
So the outer loop, the For row in range, open parenthesis, 2 close parenthesis, that's going to run once for each row in our list.
Okay.
The inner loop, for colon in range, open parenthesis, 3 close parenthesis, that's going to run 3 times once for each column.
Makes sense.
Inside the inner loop, we have that line, color equals app.colors, open bracket row, close bracket, open bracket call, close bracket. This line is actually grabbing the color at the current row and column and storing it in the variable called color.
So the first time through loops, row would be 0,
Yeah.
and col would be 0, so color would be red.
Exactly. Then col becomes 1, and color becomes orange. Then col becomes 2, and color becomes yellow. After that, the inner loop finishes, and the outer loop moves to the next row, so row becomes 1.
Yeah.
Then the inner loop starts over again with col going back to 0, 1, and 2. But this time, row is 1, so we get the colors green, blue, and purple.
Ah, I get it. So the nested loops let us go through every single color in the list one by one.
Yeah.
That's really cool.
Right. And you can use this idea for way more than just colors. The example in the source actually uses these row and col numbers to figure out where to draw colored circles on the screen.
Oh, wow. How does that work?
So they use these lines of code. Center X equals 75 plus col times 125, and center Y equals 125 plus row times 125. The col number helps determine the horizontal position of the circle, and the row number helps determine the vertical position.
I see. So the 2D list isn't just holding the colors. It's also like a map telling us where to put each circle.
Exactly. The source has this question about it. In that color example, what is the value of the color variable when row equals 1 and col equals 1?
Well, we just walked through. So when the row index is 1 and the column index is 1, we're looking at app.colors, open bracket, 1 close bracket, open bracket, 1 close bracket, which is blue.
Yep, you got it.
Okay. So we've seen how to create a 2D list with values already in it and how to go through those values using nested loops. But what if we want to create an empty 2D list first and then fill it in later?
Yeah, sometimes you might know, like, how big you want your grid to be, but you don't know what's going to go in each spot yet.
Okay.
Like, maybe you're making a game board for tic-tac-toe. You know it's going to be a 3x3 grid, but you don't know where the X's and O's are going to go yet.
Right.
In that case, it's helpful to just make the empty grid first and then fill it in as you go. The source mentions this function called makeList open parenthesis rows. Comma calls close parenthesis that does this.
Okay.
It's not like a standard Python function or anything, but it shows you how you could make one yourself. It looks like this. Def makeList open parenthesis rows, comma calls close parenthesis colon. Then indented on the next line, L equals open bracket, close bracket. Then indented again on the next line for row in range, open parenthesis rows, close parenthesis colon. Then indented one more time on the next line, L plus equals open bracket 0, close bracket times cols, close bracket. And then finally on the next line, return L.
Okay, let me see if I understand this. So it starts by creating an empty list called L. Then for each row that we want, it adds another list to L. And that inner list, open bracket 0, close bracket times cols, that's just creating a list with col's number of zeros.
You got it.
So if we called makeList open parenthesis 4, comma 5 close parenthesis, it would give us back a 2D list with 4 rows and 5 columns.
Yep.
And all the spots would have 0 in them at first.
Exactly. And the source uses this makeList function in another example called the assigning into 2D list demo.
Okay.
They create this list called app dots by calling makeList to open parenthesis 4, comma 5 close parenthesis. So now we have a 4x5 grid. Then they use nested loops again.
Okay.
But this time, instead of just reading values from the 2D list, they're actually putting stuff into it.
Oh, that's interesting.
So for each row and col combination, they create a circle object.
Okay.
And then they assign that circle object to the corresponding spot in the app.docs 2D list using app.docs open bracket row, close bracket, open bracket col, close bracket equals dot.
So it's like we're placing a dot in each spot on the grid.
Exactly. And they have this other function in the example called highlight col that shows how you can change the color of all the dots in a certain column. It's a cool way to see how you can use the row and col numbers to like find and change specific items in your 2D list.
That's really neat.
Yeah, and the source even has a question about this. In this example, what happens if we try to highlight a column that doesn't exist, like column 8, when our grid only goes up to column 4?
That's a good question.
So the code for highlighting a column is probably going to check if the column we want to highlight matches the current col variable in our loop.
Right.
But if we ask for column 8 and our loop only goes up to column 4, they're never going to match. So nothing happens. No dots get highlighted.
So we don't get an error or anything?
Nope. we're not actually trying to access anything outside of our grid, so Python's totally fine with it.
Okay, that makes sense. Whew. I
Yeah.
think that covers the main stuff from the source. So 2D lists are like tables with rows and columns.
Yeah.
We get to specific items using the row number, then the column number, remembering that Python starts counting at 0.
Right.
And if we want to do something with every item in the list, we usually use nested for loops.
Exactly.
We can create a 2D list with stuff already in it, or we can make an empty one and then fill it in as we go.
Yep. That's the gist of it.
It's cool how we can use 2D lists for so many things. You mentioned tic-tac-toe earlier. We could use a 2D list to represent the game board, right?
Definitely. Each spot in the list would be like a square on the board.
And we could store an X, an O, or like a blank space in each spot.
Exactly. And it's not just games. You could even use a 2D list to represent an image, like a grid of pixels.
Oh, wow. I never thought of that. So 2D lists are basically like the building blocks for all sorts of visual stuff.
Yeah, they can be really powerful once you start thinking in terms of grids.
And if we can have lists inside lists to make 2 dimensions, what about 3 dimensions or even more? Could we use lists to organize information in like a whole bunch of dimensions?
That's a great question, and it's definitely something to think about.
Yeah, it's like opening up a whole new world of possibilities. Well, that's all the time we have for today's deep dive. Thanks for joining us.
My pleasure. Keep exploring and happy coding.